A colossal stone block weighs more than 20 elephants, yet it fits against another without a sliver of light passing between them. How was this done without any record of the method? This video explores 25 ancient structures that hold forgotten engineering knowledge. By the end, you will see human history not as a slow climb, but as a story of brilliant peaks, deep valleys, and secrets buried in stone. We will investigate how a society without wheels moved 80-ton statues across an island, and how a 2,000-year-old dome still stands without a single piece of steel holding it up. These silent monuments ask us a profound question. What does true ingenuity look like when all the familiar tools are taken away? That single, silent question hangs in the air as we turn our gaze to the very first structure on our list. The Great Pyramid of Giza stands not merely as a tomb, but as a foundational riddle, the sole surviving wonder of the ancient world. Built around 2,560 years before the Common Era, it represents an apex of human ambition. Its scale is almost incomprehensible. Imagine a structure composed of roughly 2.3 million limestone blocks, each one quarried, shaped, transported, and set into place with a precision that defies its age. Some of these stones weigh as much as 80 tons, the equivalent of a modern passenger jet. The logistical challenge alone is staggering, a puzzle that has fueled speculation for centuries. But the true mystery lies not just in the how, but in the astonishing accuracy achieved. The pyramid's four sides are aligned to the cardinal directions with a deviation so slight it is more precise than the Royal Observatory. But what of a society that chose not to command but to converse? To listen to the earth and the sky and build a monument that acts as a bridge between them. That is the enduring whisper of Stonehenge, rising from the wind-swept Salisbury Plain in England. This iconic ring of standing stones is a puzzle carved from two distinct mysteries, transport and purpose. The scale of its construction is humbling in a different way. The largest stones, the sarcens, each weigh up to 25 tons. They were dragged from quarries over 20 miles to the north. But the smaller, distinctive bluestones tell a far more incredible story. Their geological origin lies in the Preseli Hills of Wales, a staggering 140 miles away. To move a single one of these multi-ton stones across such a distance, Neolithic people faced a monumental choice. The journey likely combined overland hauling with river and sea transport, a logistically complex operation requiring intimate knowledge of the land's waterways, tides, and terrain. This was not the work of a few individuals, but a sustained, communal effort spanning generations, a society united by a shared vision powerful enough to move literal mountains, stone by stone. Yet the true genius of Stonehenge is not just in how the stones arrived, but in why they were placed with such care. The arrangement is not random. The central axis of the monument aligns precisely with the sunrise of the summer solstice and the sunset of the winter solstice. This is not a lucky coincidence. It reveals a deep, calendrical understanding, a way of marking the year's most extreme turning points encoded directly into the architecture. Stonehenge, therefore, stands as a dual testament. It showcases a Neolithic society's remarkable ability to organize labor and navigate vast landscapes. But more profoundly, it demonstrates their desire to anchor their community within the cosmic order, to build a permanent observatory that connected their earthly efforts to the eternal cycles of the heavens. It is a feat of both brute strength and delicate observation, a seamless fusion of the terrestrial and the celestial. This pattern of uniting immense physical effort with precise, almost spiritual, alignment is a thread we will see again and again. And as we follow it, we find ourselves drawn to a place where this fusion created not just a monument, but an entire city suspended between cliff and sky. From the celestial calendar of Stonehenge, our journey takes us to the most isolated open-air museum on Earth. Easter Island, or Rapa Nui, is a speck of volcanic rock in the vast emptiness of the South Pacific, over 2,000 miles from the nearest continent. Here, a society not only survived but thrived, and in their ambition, they created one of humanity's most enigmatic legacies, the Moai. These monolithic stone figures, with their solemn, elongated faces and heavy brows, stand as silent sentinels along the coastline, their backs perpetually turned to the sea. They are guardians, ancestors made permanent in stone, and their creation story is a masterclass in ingenuity born from profound isolation. Each Moai began its life within the slopes of the Rono Raraku quarry, a volcanic crater where the rock is a unique, workable, compressed volcanic ash. Sculptors, using only stone hand tools, would painstakingly carve the giant figure directly from the crater wall, first defining the face, then the body, until it remained attached by a single stone keel along its back. Once freed, the statue would be carefully lowered down the quarry slope, a descent that itself required immense skill to prevent the multi-ton figure from shattering. Some of these figures are truly colossal, standing over 30 feet tall and weighing as much as 80 tons, the equivalent of a full-grown blue whale. But the quarry was only the beginning. The true, mind-bending puzzle lies in the journey that came next. These gigantic stone beings were then transported, sometimes for miles across the island's rugged, undulating terrain, to their final resting places on coastal ceremonial platforms known as ahu. How did a people with no metal, no wheels, and no large draft animals move an 80-ton stone statue across such a distance? For decades, the prevailing theory involved log rollers and large teams pulling with ropes, a method of brute force. But a more compelling, almost poetic idea has gained ground, one that makes the statues seem less like inert cargo and more like participants in a ritual procession. It is called the walking theory. Imagine teams of skilled workers using 3 sets of ropes, one on each side to rock the statue, and one at the back to control its forward tilt. By rocking the Moai side to side in a coordinated rhythm, they could, in essence, make the statue walk itself forward in a slow, controlled shuffle. This method leverages the statue's own weight and center of gravity, turning its massive bulk from a liability into an asset. Modern experiments have shown this technique is not only possible but remarkably efficient, requiring far fewer people than previously thought. It speaks to a deep, intuitive understanding of physics, balance, and collective human rhythm. This was engineering as a form of choreography, a symphony of coordinated effort that allowed a community to literally walk their ancestors across the landscape. Yet this story of brilliant adaptation carries a sobering echo. The very ambition that produced the Moai, the consumption of vast timber resources for transport and leverage, is intertwined with the island's ecological transformation. It prompts a reflection on the delicate balance between human innovation and the environment that sustains it. Here, on this remote island, we see the pinnacle of what a determined society can achieve with nothing but stone, rope, and shared purpose. It forces us to redefine the limits of possibility, to understand that our ancestors' toolkits were not defined by what they lacked, but by the profound depth of what they understood. And as we contemplate this island of walking giants, we are drawn to another ancient wonder, one that solved a different kind of earthly challenge, not by moving across the land, but by mastering the very water that flowed beneath it. Isolation forced one society to move mountains of stone, but a different kind of challenge faced the engineers of Rome. Here, the goal was not transport, but permanence, to create a space so vast and so enduring it would defy the very passage of time. In the heart of the Eternal City stands the Pantheon, a temple-turned church that represents perhaps the single most influential architectural achievement of the ancient world. Its secret is not in the stones it moved, but in the material it poured and perfected, concrete. For nearly 2,000 years, this structure has weathered earthquakes, fires, and the slow decay of empires, and its crowning glory remains a feat of engineering so advanced it would not be surpassed for over 1,300 years, the massive, unreinforced concrete dome. To stand beneath it is an experience that still hushes visitors into silence. The dome's interior is a perfect hemisphere, its diameter a breathtaking 142 feet, wide enough to fit the entire Statue of Liberty beneath it, base and all. And yet, there is no steel skeleton holding it up, no hidden framework of modern reinforcement. The entire weight of this colossal stone and concrete ceiling rests solely on the cylindrical drum of walls below. The Romans achieved this not through magic, but through a masterful, empirical understanding of material science. Their genius was in the recipe. They did not use a uniform concrete throughout. Instead, they graded the mixture with strategic brilliance. At the thick, heavy base of the dome, they used dense, strong concrete made with heavy basalt aggregate. But as the dome curved upward, they progressively lightened the load. They switched the aggregate to lighter stones, and finally, at the very top, they used porous, honeycombed volcanic pumice, a material so light it almost floats. This created a dome that was strongest where the stress was greatest, at its base, and lightest at its crown, where any extra weight would have been catastrophic. This was intuitive structural engineering of the highest order, a calculated distribution of mass and force long before the mathematical formulas to describe it existed. And at the very apex of this mountain of concrete, they placed their most daring stroke of genius, the oculus. This 27-foot wide circular opening is not a structural weakness, it is the key to the dome's survival. The oculus acts as a natural compression ring, the keystone of the entire structure, relieving stress and preventing the dome from cracking under its own weight. But its purpose was dual. It is also the building's only source of natural light, a beam that tracks across the interior floor and walls like a celestial clock, connecting the human space below directly to the heavens above. The Pantheon is more than a building, it is a permanent lesson. It reveals a civilization that possessed a profound, hands-on knowledge of physics and materials, a knowledge so complete they could build for eternity. Yet, in the centuries that followed its completion, the precise recipes and techniques for this Roman concrete were lost, buried by the collapse of the empire that created them. Modern science is only now beginning to fully unravel its secrets, discovering that the Roman concrete actually grows stronger over time as seawater reacts with its ingredients, a self-healing property we are just learning to replicate. The Pantheon stands as a quiet rebuke to the idea of linear progress, a reminder that pinnacles of knowledge can be reached and then, astonishingly, forgotten. It makes us wonder what other empirical masterpieces, other perfect unions of material and form, are waiting to be rediscovered in the silent testimony of ancient stone. The Pantheon's dome is a monument to physical mastery, a triumph over gravity and material. But what of a triumph over time itself, a machine built not to stand still, but to calculate the future? In the silent depths of the Aegean Sea, just off the coast of a tiny Greek island, a shipwreck held a secret that would shatter our understanding of ancient technology. In the year 1901, sponge divers discovered a lump of corroded bronze and wood, its form so encrusted and misshapen it was initially set aside with other artifacts. Decades later, someone looked closer. This object, now known as the Antikythera mechanism, is not a statue or a weapon. It is a clockwork puzzle, a device of such staggering complexity that it has been called the world's first analog computer. Scientific dating places its creation around the 2nd century before the Common Era, a time when Rome was still a republic and the great library of Alexandria still stood. The mechanism itself, about the size of a large dictionary, was housed in a wooden case with bronze dials on the front and back. When a hand crank on its side was turned, a symphony of at least 30 interlocking bronze gear wheels, some with teeth cut with astonishing precision, would spring into motion. These gears did not power a mill or move a vehicle. They moved pointers across inscribed dials to model the cosmos. This device could predict the positions of the sun and the moon, the phases of the moon, and the timing of solar and lunar eclipses with remarkable accuracy. It could even track the 4-year cycle of the ancient Olympic Games. To achieve this, its unknown creators had to solve profound mechanical problems. One of its most brilliant features is a differential gear, a complex arrangement that allows 2 rotational speeds to be combined to produce a third corrected output. This technology, essential for the mechanism's lunar calculations, was not thought to have been invented until the 16th century, nearly 1800 years later. The implications are breathtaking. This single artifact, recovered by chance from the seafloor, implies an entire hidden chapter of Hellenistic science. It tells us that a group of ancient Greek thinkers and artisans possessed a level of mechanical engineering and precision, metalworking that we never knew existed. They had translated abstract astronomical theories into tangible, moving metal, creating a portable model of the heavens. The knowledge required to design, gear, and calibrate such a device represents a technological peak that simply vanishes from the historical record. After the Antikythera mechanism, similar devices of such complexity do not reappear in Europe until the astronomical clocks of the medieval period. Its existence forces a humbling question upon us. If this one incredible object survived only by the sheer luck of a shipwreck, what other tools, what other libraries of mechanical wisdom were lost in the fires of libraries, the decay of empires, or the simple erosion of time? This is not just a forgotten machine. It is a ghost, a whisper from a past that was far more mechanically sophisticated than we ever dared to imagine. And it challenges us to look at every other ancient artifact with new eyes, wondering what secrets might still be locked inside, waiting for the right key. The Antikythera mechanism was a machine for modeling the cosmos, a private wonder held in the hands. But what of an engineering feat so vast it could only be seen by the gods? Shift the scene from the blue Aegean to the stark, sun-baked plains of southern Peru. Here, the Nazca culture left a legacy not in towering stone, but in the skin of the earth itself. Between 500 years before the Common Era and 500 years after, they transformed hundreds of square miles of desert into the world's largest and most mysterious art gallery. These are the Nazca lines, colossal geoglyphs etched into the arid plateau. They are not mere scratches. They are precise, sweeping depictions of a hummingbird with wings outstretched, a spider with intricate legs, a monkey with a spiraling tail, and countless geometric shapes, trapezoids, and lines that stretch to the horizon. The method of creation seems deceptively simple. The desert floor here is covered with a layer of dark, oxidized pebbles. By removing these stones along a planned path, the artists exposed the lighter, sandy soil beneath, creating a high-contrast line that has endured for over a millennium. But this apparent simplicity is the heart of the deception. The true engineering marvel lies in the scale and the precision. Some of these straight lines run for over 30 miles across broken, uneven terrain without deviating more than a few feet. The animal figures, some over 300 feet long, maintain perfect proportions even when their curves span the length of multiple football fields. This was not doodling. This was large-scale, permanent landscape architecture executed with cartographic accuracy. How did they achieve such flawless symmetry and alignment without ever seeing their work from above? The prevailing theory points to a mastery of basic, yet brilliantly applied, surveying techniques. Small-scale models could have been first created on prepared grids. Teams on the ground could then have transferred the design using a system of stakes and cords, scaling it up with meticulous care. By using a central hub point and measured ropes as a giant compass, they could create perfect circles and radiating lines. Maintaining straight paths over miles would have required a series of aligned sighting markers, perhaps simple posts on distant hills, demonstrating a profound understanding of line-of-sight geometry. This was engineering of perception. It required an individual on the ground to hold a mental image of a spider or a condor so completely that they could direct its creation one carefully placed stone at a time, trusting in a plan they would never witness in its full glory. The purpose of these lines continues to spark debate, with theories ranging from astronomical calendars to pathways for ceremonial processions, but their legacy is clear. They represent a unique form of knowledge, a forgotten science of spatial reasoning and communal coordination. The Nazca engineers worked not with pulleys and concrete, but with perspective, patience, and a shared vision literally written into the earth. They turned the entire landscape into their canvas, proving that the most profound constructions are sometimes not those that reach for the sky, but those that ask us to change our point of view entirely. While the Nazca lines were a canvas for the gods, a different ancient people were building chambers to commune with them. On the sun-drenched islands of Malta, nestled in the heart of the Mediterranean, stand the silent, stoic ruins of the megalithic temples. Their age is the first detail that stops you cold. Structures like Giza, dot above Gantija on Gozo and Haga Kim on Malta itself were erected between 3,600 and 2,500 years before the Common Era. This means they are older than Stonehenge. They are older than the Great Pyramid of Giza. They are among the very oldest free-standing stone structures ever created by human hands, a fact that quietly reshapes our mental timeline of architectural ambition. Walking among these ruins today, you are greeted by a labyrinth of semicircular chambers called apses connected by central corridors. The walls are built from colossal limestone blocks, some weighing many tons, fitted together with a careful, patient skill. But look up, or rather, look at the spaces where ceilings once were. Here we find one of their signature engineering innovations, the corbelled roof. This was not a single slab laid across a space, which would have been impossible with their tools. Instead, they used a technique of incremental overhang. Each successive course of stones was laid slightly inward over the one below, slowly narrowing the gap until a final capstone could close it. This created a domed, beehive-like interior, a self-supporting vault that distributed weight down through the walls. It was an early, brilliant solution to the fundamental problem of roofing a large space without modern beams or arches. Moving these multi-ton blocks into position required another flash of mechanical insight. Archaeologists have discovered at the temple sites numerous perfectly spherical stone balls, each about the size of a large melon. These were not game pieces. They are believed to have been used as primitive ball bearings. The theory is compelling. A massive stone slab could be levered onto a track of wooden rollers, but friction would make it incredibly difficult to steer. By placing these hard, smooth stone spheres in a carved wooden channel or between two planks, the builders could reduce friction dramatically, allowing a small team to pivot and guide the block with far greater control. It was a simple bearing system, a fundamental mechanical principle being applied over 5,000 years ago by a society that had not yet entered the Bronze Age. The temples, however, speak of more than just moving weight. They hint at a holistic vision where engineering served a deeper sensory and social purpose. The layouts are not random. They follow sophisticated plans that suggest a progression from public outer spaces to more intimate, hidden inner chambers, possibly mirroring a spiritual journey. Even more intriguing is the emerging study of their acoustics, the shapes of the limestone chambers, the placement of niches, and the specific resonance of the stone itself may have been designed to alter sound. A voice spoken or a ritual chant made in certain spots could be amplified or distorted, creating an otherworldly auditory experience for ceremonies. This suggests the builders understood their material not just as a structural element, but as a medium that could shape atmosphere and emotion. What emerges from Malta is the portrait of a pre-literate, pre-metal society that possessed something extraordinary, a unified engineering philosophy. Their projects required advanced communal organization to quarry, transport, and construct over generations. They employed basic but effective mechanics to solve transportation puzzles. And they designed their spaces with an intuitive understanding of how form, material, and sound could work together to create a powerful, immersive environment. This was not engineering divorced from purpose. It was a seamless integration of the physical, the social, and the spiritual, a forgotten testament to the fact that the earliest builders sought not just to create shelter, but to sculpt experience itself from solid stone. The silent, patient temples of Malta speak of a world built by touch and sound. But on a different continent, high in the Andes Mountains, another civilization achieved a mastery of stone so absolute it seems to defy the very nature of solid matter. Above the ancient Inca capital of Cusco, the fortress of Sacsayhuamán sprawls across a hilltop, its most famous feature a series of 3 zigzagging walls that ripple across the landscape like frozen stone waves. To stand before them is to feel a deep, instinctual sense of awe followed by a profound puzzle. These are not merely stacked rocks, they are a symphony in limestone, composed of blocks so enormous they beggar belief, some weighing well over 100 tons, the equivalent of a large commercial jetliner. Yet the true wonder is not their size but their intimacy. Each of these colossal stones is cut and shaped with a precision that feels impossible. The joints between them are so seamless, so perfectly fitted, that you cannot slide a piece of paper or even the blade of a knife into the cracks. And all of this was accomplished without a single drop of mortar. This is the pinnacle of dry stone masonry, a forgotten art the Incas called ashlar. The process was one of breathtaking patience and empirical genius. Imagine a team of craftsmen facing a newly quarried block of limestone. Their tools were not iron or steel, but other, harder stones like diorite or quartzite. Through a meticulous process of trial and error, they would slowly shape the block, grinding and polishing its faces, not to a flat plane, but to a unique, 3-dimensional puzzle piece. Each stone was custom fitted to its neighbors, with multiple contact points across its surface. This was not a quick assembly. It was a slow, deliberate act of stone knitting, where every block had to be tested, adjusted, and tested again until it settled into its place with a hushed, final certainty. But the genius of these walls extends beyond mere fit. Look closely at their profile. They are not vertical. The walls slope inward as they rise, a subtle but critical design choice. This inward slant, combined with the complex interlocking shapes of the stones, gives the entire structure a remarkable flexibility and resilience. In a region violently shaken by frequent earthquakes, this was not an aesthetic choice, it was an act of profound foresight. When the ground trembles, a rigid wall wants to crack and collapse. The walls of Sacsayhuamán, however, are designed to dance. The sloping, interlocked stones allow the structure to shift and settle during a tremor, the energy dissipating through the countless tiny friction points between the blocks. When the shaking stops, the stones simply settle back into their original, locked embrace. This is engineering as a dialogue with the earth, a structure that understands the forces arrayed against it and chooses not to resist but to move with them. It represents a pinnacle of forgotten knowledge, a deep, intuitive understanding of materials, geometry, and seismic force, all achieved through observation, patience, and a communal skill so refined it turned mountain rock into something resembling a living, breathing entity. In these silent walls, we see a philosophy made stone, a testament to the idea that true strength lies not in rigid defiance, but in intelligent, resilient connection. The resilient stone walls of Sacsayhuamán were built to withstand the visible tremors of the earth. but in the heart of Turkey's otherworldly Cappadocia region, an entire civilization chose a different kind of resilience, one that moved not with the shaking ground, but deep beneath it. Here, the landscape is a fantasy of soft volcanic rock, sculpted by time into towering cones and undulating valleys. And within this soft stone, ancient engineers performed their most astonishing feat of all. They carved not a single structure, but an entire inverted city. This is Derinkuyu, a subterranean metropolis that plunges over 200 feet into the earth, a labyrinth of tunnels, chambers, and vertical shafts that could shelter as many as 20,000 people. Its construction began in the early first millennium, a project of such scale and complexity, it redefines our understanding of ancient urban planning. The soft volcanic tuff of Cappadocia was ideal for carving, but carving a stable, multi-level city from it was an engineering puzzle of the highest order. This was not a single, vast cavern. It was a meticulously planned vertical settlement with 18 discovered levels descending into the cool, silent darkness. Each level served a distinct purpose, from upper floors for living quarters and stables for livestock, to deeper chambers for communal kitchens, churches, and even wineries. The architects had to solve the fundamental problems of any city, but in a completely inverted, confined environment. Fresh air was the first and most critical challenge. Without it, the city would become a tomb. Their solution was a masterpiece of passive engineering, a network of over 50 ventilation shafts. These narrow, vertical channels were drilled with precision from the deepest chambers all the way to the surface, sometimes over 200 feet above. They functioned like a natural lung for the city, allowing cooler, denser air from below to draw fresh oxygen from the surface through convection, creating a continuous, life-sustaining breath without any mechanical aid. Water was supplied by deep, protected wells, tapped into the groundwater table far below, ensuring a supply safe from contamination on the surface. Waste management was handled through carefully sloped tunnels and sealed pits, preventing the spread of illness in the close quarters. But perhaps the most brilliant feature was its security design. The entire city could be sealed from the inside. Massive, circular stone doors weighing up to a ton could be rolled across key passageways from within, effectively isolating each level. These were not just doors, they were defensive bulkheads, allowing the inhabitants to control any incursion inch by inch, level by level. Derinkuyu reveals a society with a profound, holistic understanding of geology, physics, and human needs. They knew their material, the soft but stable tuff. They understood airflow and hydrology. They planned for sanitation, spiritual life, and communal gathering, all within a defensive fortress carved from the living rock. This was engineering turned inward, a testament to the human capacity to create not just monuments that scrape the sky, but entire hidden ecosystems for survival. It stands as a powerful reminder that ancient ingenuity was not a single note, but a vast spectrum capable of building soaring pyramids, moving stone giants, and crafting vast, silent cities in the Earth's own embrace. The hidden cities of Cappadocia prove ancient builders could reorder the world beneath their feet. Yet another discovery, made entirely by accident, suggests they could also vanish an entire mountain from within. In 1992, a farmer in Zhejiang province, China, decided to pump water out of a small, local pond. As the water level dropped, he revealed not a muddy bottom but a vast, dark opening. This was the first glimpse of the Longyou caves, a network of 24 colossal, hand-carved caverns that had lain hidden for 2 millennia. What he discovered was not a natural formation, but an artificial space of breathtaking scale and eerie precision, a ghost project from antiquity with no name, no record, and no clear purpose. Each cave is a monumental room carved into a solid hill of hard siltstone. The sheer volume of material removed is almost impossible to grasp, estimated at nearly 1 million cubic meters of rock. To put that in perspective, it is like excavating a hole large enough to contain the Great Pyramid of Giza and then doing it again. This was not a haphazard digging operation. It was a coordinated architectural undertaking of staggering ambition. The walls and ceilings of every chamber are covered in a uniform pattern of parallel chisel marks, each about 2 inches wide, running in precise, unbroken bands across vast surfaces. This consistent texture is not just decorative, it is the fingerprint of a systematic, disciplined workforce, all following the same technique with an almost mechanical rhythm. The structural planning is equally sophisticated. Inside each cave, the ancient engineers left behind massive, rectangular pillars of untouched rock, strategically positioned to support the immense weight of the ceiling above. The angles where walls meet are sharp and true, the surfaces flat and smooth, demonstrating a masterful control over geometry and form. They carved staircases, pools, and even gutters for water drainage, all integrated into the rock itself. This was not a mine, for there is no evidence of valuable ore removed. It feels more like a subterranean temple or a grand communal space, but one utterly devoid of the carvings, inscriptions, or artifacts that usually accompany such places. And here lies the core of the mystery. A project of this magnitude, requiring the labor of countless workers over generations, simply vanishes from history. No scroll, no stele, no local legend even hints at its construction. The engineering knowledge on display is profound. Sophisticated quarrying to remove such volume without collapse, advanced structural understanding to plan the support pillars, and possibly even intentional acoustic or lighting design, as the caves possess a strange, resonant quality. Yet the blueprint, the reason, and the very memory of its creators have been completely erased. The Longyou caves stand as a silent question mark carved in stone. They force us to confront a humbling possibility, that entire chapters of human endeavor, entire schools of engineering thought, can be so thoroughly forgotten that their greatest works are mistaken for natural wonders, waiting centuries for a curious farmer to reveal them once more. The silent, unrecorded ambition of Longyou leaves us with a ghost, but in the sun-drenched Bekaa Valley of Lebanon, we find a monument that shouts its scale to the heavens, yet still guards the secret of its birth. This is the temple complex of Baalbek, a Roman masterpiece built upon a foundation of staggering, almost incomprehensible pre-Roman mystery. While the soaring columns and ornate carvings of Jupiter's temple capture the eye, the true engineering enigma lies beneath them, in the platform upon which the entire complex rests. Here, set into the lowest course of the western retaining wall, are 3 blocks known as the Trilithon. Each one is a behemoth of limestone, measuring roughly 64 feet long, 14 feet high, and 12 feet deep. Their weight is the staggering figure, each one estimated at around 800 tons. To grasp that scale, imagine 3 fully loaded Boeing 747 jets, each one seamlessly carved from a single piece of stone, and then fitted against its neighbor with a joint so tight it challenges perception. The Romans, master builders in their own right, built their glorious temples directly atop this platform, perhaps in awe of the foundation they had inherited. But the story of scale does not end there. A short distance from the temple, in the ancient quarry that supplied the stone, lies an even more mind-bending artifact. This is the stone of the pregnant woman, a single, partially extracted block still attached to the bedrock. Its dimensions are colossal, nearly 70 feet long, and its estimated weight is a breathtaking 1,650 tons. It is the largest known piece of stone ever cut by human hands. These numbers are so vast they risk becoming abstract, so let's make them concrete. That single quarry block weighs more than 250 large African elephants. It is heavier than a modern naval destroyer. the logistical challenge it represents is not just a step beyond the pyramids or the Moai, it is a leap into an entirely different category of ambition. The knowledge required to even attempt such a feat points to a lost school of engineering, a forgotten mastery of logistics and mechanical advantage. How do you move a small mountain? The likely method involved a symphony of basic principles pushed to their absolute limit. The block would have been undercut and levered onto a prepared bed of log rollers. From there, teams of hundreds, perhaps thousands of men and oxen would have pulled with ropes along a carefully greased track, a road engineered to be as level as humanly possible. Levers and capstans would have provided incremental adjustments for steering. The process would have been agonizingly slow, a matter of inches per hour, requiring relentless coordination, immense social organization to feed and house the workforce, and a fearless confidence that the year or decade-long effort would succeed. This was physics made manifest through sheer human and animal power, a testament to what is possible when a society directs its entire will toward a single, monumental task. The Baalbek megaliths stand as a boundary stone in the history of engineering. They mark the outer limit of what we believe was possible in the ancient world with organic materials, ropes, wood, and muscle. They push against our assumptions, asking us if we have underestimated the innovative potential of pre-industrial societies when united by a vision that literally moved mountains. In these stones, we see not just forgotten technique, but a scale of ambition that dwarfs even the later Romans who built upon their backs, a whisper from a time when giants seemed to walk the earth, leaving their calling cards in limestone for us to puzzle over millennia later. Baalbek's megaliths represent a pinnacle of mass, a conversation with weight itself. But what of a structure that converses not with the earth, but with the stars, using a language of geometry written in mud and stone? In the high valley of ancient Mexico, the city of Teotihuacan once pulsed with life, a metropolis so grand its very name means the place where the gods were created. At its heart stands the Pyramid of the Sun, a colossal earthen mountain constructed around 200 years after the Common Era. Its scale is immediately humbling, rising over 200 feet high with a base covering nearly the same area as the Great Pyramid of Giza. This similarity in footprint is the first tantalizing whisper of a deeper mystery, a shared architectural echo across impossible distances. But the true genius of this pyramid is not in its size alone, but in the specific, ingenious way it was built and precisely what it was built to see. The builders of Teotihuacan worked with the materials at hand, and their primary tool was earth itself. They employed a technique known as talud table row, a signature style that gives the pyramid its distinctive silhouette. Each level consists of two parts, a sloping base, the talud, topped by a vertical panel, the table row. This was not merely an aesthetic choice, it was a brilliant structural solution. The core of the pyramid is a massive mound of millions of sun-dried mud bricks, a material vulnerable to erosion from the heavy seasonal rains. The stone-faced talud table row design acted as a permanent protective skin. The sloping sections efficiently shed water away from the earthen core, while the vertical panels provided a stable, finished surface for decoration and ritual. This was large-scale architecture engineered for permanence in a specific climate, a testament to a deep understanding of local materials and environmental forces, all achieved without metal tools or the wheel. Yet the pyramid's most profound dialogue is with the sky. Unlike the cardinal alignment of Giza, the Pyramid of the Sun is oriented slightly off true north, a deliberate choice that has long puzzled researchers. The answer appears not on the ground, but in the heavens. The western face of the pyramid aligns precisely with the point on the horizon where the Pleiades star cluster, known to many Mesoamerican cultures as a celestial marker of great importance, sets on a key date in the ancient calendar. This alignment transforms the pyramid from a static monument into a dynamic astronomical instrument. Its bulk becomes a giant gnomon, casting shadows and framing celestial events, tying the rhythm of the city directly to the cycles of the cosmos. This brings us back to that haunting geometrical echo, its base perimeter mirroring that of the Great Pyramid. Two cultures separated by an ocean and over 2,000 years of history, with no evidence of contact, each chose the same massive scale for their central monument. Could this be a staggering coincidence, or does it point to something more fundamental, a shared human intuition about sacred geometry, a mathematical or astronomical principle discovered independently? Perhaps both civilizations, through deep observation of the heavens and the earth, arrived at a similar expression of cosmic order, a proportion that felt inherently powerful and correct. The Pyramid of the Sun stands as a monumental synthesis, a mountain of earth protecting a celestial observatory, its form speaking a language of both practical engineering and profound astronomical intent. It reminds us that ancient knowledge was often holistic, seeing no separation between building a stable structure and mapping the passage of the stars. The pyramids of Teotihuacan speak a language of earth and stars, a dialogue with the cosmos. But on the slopes of the Athenian Acropolis, a different conversation was taking place, one between stone and the human eye. The Parthenon, completed in the year 432 before the Common Era, is universally hailed as the pinnacle of classical Greek architecture, a temple of such serene perfection it seems to have been born, not built. Yet this very appearance of effortless harmony is its greatest deception, a masterful illusion crafted through a forgotten science of perception. To the casual observer, the Parthenon presents a vision of flawless straight lines and perfect right angles. But almost nothing about it is actually straight. This was not a mistake. It was a deliberate, sophisticated series of optical refinements, an ancient form of visual engineering. The most famous of these is a subtle feature known as intosses. Look closely at any of the Parthenon's 46 outer columns. They do not taper in a straight line from bottom to top. Instead, they swell ever so slightly about 1/3 of the way up, creating a gentle, convex curve before narrowing again at the capital. This bulge is minute, barely more than an inch, but its effect is profound. A perfectly straight column, when viewed against a bright sky, can appear to concave inward, as if it is bending under the weight it carries. The architects of the Parthenon understood this trick of light and perspective. By introducing a countercurve, they made the columns appear strong, straight, and resilient, correcting the eye's natural error. This was engineering that accounted for human psychology as much as physics. But the illusions run deeper. The entire platform upon which the Parthenon sits is not flat. It curves upward at its center, rising about 4 inches higher in the middle of its long sides than at the corners. This subtle arc prevents the massive structure from appearing to sag, giving the visual impression of a platform that is taut and perfectly level. Furthermore, the columns themselves do not stand perfectly vertical. They all lean inward just a few inches from base to top, and the corner columns are slightly thicker than the others. If these lines were extended upward, they would eventually meet about 1.5 miles above the temple. This inward lean accomplishes two things. It creates a sense of dynamic stability, as if the temple is gathering itself, and it counteracts another visual effect where parallel vertical lines can appear to splay outward when viewed from below. Every single one of these refinements, from the swelling columns to the curved floor, required incredibly precise mathematical calculation. The builders were working with a deep understanding of geometry and proportion, but they were applying it to solve a problem that wasn't purely structural. It was aesthetic and perceptual. They recognized a profound truth that mathematical perfection on the drafting table does not always translate to visual perfection in the real world. The human eye, with its biases and its place in a three-dimensional landscape, sees differently than a ruler measures. This represents a lost art, a fusion of art, mathematics, and cognitive science in marble. The Parthenon's architects weren't just building a temple to Athena. They were building an experience, carefully calibrating every line to create a feeling of ideal harmony and divine presence for the approaching worshipper. This principle of optical correction, this willingness to bend literal truth to achieve a higher perceptual truth, is a subtlety that largely vanished from later architectural traditions. It stands as a quiet testament to a level of holistic design thinking where beauty was not an afterthought, but an engineering parameter as critical as load-bearing capacity. In these gentle curves and intentional leans, we see a forgotten dialogue between the mind that builds and the eye that beholds, a reminder that the greatest structures are often those that understand us as well as the stone they are made from. The Parthenon's architects mastered the art of visual perception, bending stone to shape our experience. But what happens when the primary goal of engineering is not to reach for the sky, but to plunge deep into the earth in a desperate, beautiful search for life's most basic element? In the arid landscape of Rajasthan, India, the answer is not a tower but an inverted palace dedicated to water. This is Chand Bayori, a stepwell built in the 9th century, a structure that redefines the very concept of a public building. From the surface, it appears as a geometric mouth opening in the flat earth, but to step inside is to enter another world, a breathtaking cascade of symmetry descending into cool, shadowed silence. The scale is vertiginous. Chand Bayori plunges over 100 feet down, the equivalent of a modern 13-story building constructed in reverse. Its walls are a mesmerizing lattice of precisely carved steps, 3,500 of them, arranged in a flawless, repeating pattern on 3 sides. This is not a simple staircase. It is a monumental geometric sculpture, a testament to a culture that saw divine order in mathematics and infused it into the most practical of civic works. The engineering challenge here was twofold, and both solutions are works of genius. First, and most critically, was the hydrological mastery. Rajasthan is a land of extreme heat and unreliable rainfall. Surface water vanishes quickly. The builders of Chand Bayori possessed a deep, empirical understanding of the local water table. They knew exactly where to dig to intersect the subterranean aquifer, and they designed the entire structure to harvest every precious drop of seasonal rainwater, channeling it into the deep reservoir at the bottom. This ensured a reliable, year-round water source for the surrounding community, turning a place of scarcity into one of security. The second challenge was structural. Excavating such a vast, deep pit and lining it with stone creates immense lateral pressure from the surrounding earth. The walls want to collapse inward. The builders countered this force with the staggering precision of their masonry. The steps are not merely a walking surface, they are an integral part of the wall's buttressing system. Their precise, interlocking arrangement and the overall pyramidal shape of the excavation distribute the Earth's pressure evenly, creating a stable, permanent cavity. But the genius of Chand Bayori extends beyond survival. It created an oasis in every sense. As you descend, the air grows noticeably cooler, a natural effect of the deep, shaded stone and the evaporating water below. This transformed the stepwell from a mere water source into a vital social space, a communal refuge from the blistering heat where people could gather, converse, and find respite. It represents a holistic philosophy of engineering, where a solution to a critical survival need water security and climate mitigation was executed with such geometric elegance and social foresight that it became a place of profound beauty and community. Chand Bayori stands as a powerful counterpoint to the pyramids and temples that dominate our imaginations. Here, the greatest architectural achievement is a humble, glorious embrace of the earth, a surrender downward to sustain life upward. It proves that the most forgotten engineering knowledge is sometimes not about moving mountains, but about listening to them, understanding the hidden water they hold and building a staircase to meet it. The stepwells of India surrender into the earth to find life, but in the sweltering heat of early 20th century Florida, a different kind of surrender took place, one of a man to a monumental private obsession. Near the city of Homestead stands Coral Castle, a sprawling complex of megalithic sculptures and structures fashioned entirely from oolitic limestone. Its creator was a single individual, an immigrant from Latvia named Edward Leedskalnin. Between 1923 and 1951, working almost entirely alone and mostly at night, he quarried, carved, moved, and assembled over 1,100 tons of stone. The individual blocks are staggering, with the largest weighing an estimated 30 tons. This is not ancient history. This is a modern mystery, a puzzle from an era of automobiles and radios, built with the apparent tools of the distant past. Leedskalnin was a man of slight build, standing just 5 feet tall and weighing barely 100 pounds. Witnesses reported his toolkit consisted of little more than simple hand tools, chains, tripods, and blocks of scrap metal. Yet with these rudimentary implements, he achieved feats that seemed to defy physics. He crafted a 9-ton gate that swings open with the gentle push of a single finger, so perfectly balanced on a metal rod that it moves without a sound. He erected a 22-ton obelisk. He built walls from multi-ton blocks fitted together without mortar, and even carved a functioning sundial accurate to within 2 minutes. When asked how he managed it, Leedskalnin offered only cryptic clues. He spoke of having rediscovered the building secrets of the ancient Egyptians, the pyramids. He wrote pamphlets about magnetism and cosmic forces, suggesting he had unlocked principles of weight and leverage that the modern world had forgotten. He claimed to understand the laws of matter and the nature of celestial forces, implying he could negate or manipulate gravity itself. While mainstream science dismisses these claims, the physical evidence of Coral Castle remains stubborn and inexplicable. Could one man, using only primitive tools, truly move 30-ton stones through sheer leverage and clever pulley systems? Some researchers propose he may have mastered a forgotten practical knowledge of counterweights and fulcrums, using the stone's own mass against itself in a continuous, patient dance of balance. Others wonder if he stumbled upon a principle of acoustic or harmonic resonance, finding a specific frequency that temporarily made the massive blocks easier to move, a concept hinted at in some ancient legends. Edward Leedskalnin took his precise methods to his final resting place, leaving behind only the silent, sun-bleached testimony of his work. Coral Castle, therefore, stands as a profound and haunting echo. It is a 20th-century monument that screams an ancient question. It forces us to confront the possibility that the greatest forgotten engineering knowledge may not always be locked in the distant past. Sometimes it might be something a single determined individual could rediscover, a set of principles so elegantly simple they hide in plain sight, waiting for someone to look at stone, rope, and leverage with entirely new eyes. This idea that profound secrets might be accessible through unconventional thinking pulls our gaze from the swamps of Florida to a windswept plateau in South America, where the stones themselves seem to have been softened by a forgotten hand. Coral Castle's solitary obsession suggests that forgotten principles might be rediscovered by a single mind. But what happens when an entire community channels that same innovative spirit not on the ground, but directly on the face of a mountain? Clinging to a sheer cliff in China's Shaanxi province, the Hanging Temple of Hengshan is a sight that seems to defy not just gravity, but logic itself. Constructed in the 5th century, this wooden complex appears to float against the vertical rock, a delicate lattice of halls, bridges, and pavilions bolted to the precipice over 200 feet above a river canyon. It was not built for isolation, but for protection, a sanctuary designed to survive the very elements that make its location seem impossibly hostile. The river below could flood with devastating force. The mountain pass is a funnel for fierce, relentless winds, and the region is prone to earthquakes. A conventional structure on the valley floor would have been vulnerable to all three, so the builders chose a different path, literally. They turned the problem into the solution by making the cliff itself the foundation. The engineering is a masterclass in adaptive design, a forgotten branch of architecture that viewed natural topography not as an obstacle but as a structural partner. The temple's support system relies on an ingenious combination of natural shelf and human ingenuity. A natural rock ledge provides a partial, uneven foundation. From this, the builders extended the structure outward using a network of oak crossbeams. These thick, resilient timbers were fitted into deep holes meticulously chiseled into the solid cliff face. This is the ancient principle of the cantilever in one of its most daring applications. Imagine a diving board fixed at one end, supporting weight out over the void. Each beam acts in this way, transferring the load of the wooden pavilions back into the immense, immovable mass of the mountain. The entire structure is essentially an extension of the cliff, a wooden graft onto a stone body. But the real genius lies in its flexibility. A rigid building on a cliff would shatter in an earthquake or snap in a gale. The hanging temple, however, is designed to sway. The oak beams have a natural give, and the joinery allows for slight movement. This flexibility lets the temple absorb and dissipate the energy of tremors and wind buffeting, dancing with the forces rather than resisting them. It is a living dialogue between wood and stone, between human craft and geological permanence. This temple reveals a profound, holistic engineering philosophy that has largely faded from modern practice. It embodies principles of integration and harmony, where the success of the structure is entirely dependent on a deep understanding of the site's specific conditions, the rock's composition, the wind patterns, the seismic history. There was no forcing a foreign blueprint onto this landscape. Instead, the landscape dictated the blueprint. This is forgotten knowledge of the highest order, a reminder that sometimes the most advanced engineering looks not like conquering nature, but like learning to hold its hand. The hanging temple's wooden beams whisper a conversation with the rock itself, a testament to building in harmony with a specific, unforgiving place. But the Roman Empire approached the landscape with a different philosophy, one of absolute dominion, reshaping continents not for a single sanctuary, but to fuel the very engine of urban civilization. In the heart of Spain, the city of Segovia is crowned by an engineering marvel that embodies this imperial will, a structure so functional and so permanent it has become the city's soul. The Roman aqueduct of Segovia is not a ruin. It is a working machine, a two-tiered arcade of soaring granite arches that has carried fresh water into the urban center for nearly 2,000 years. Built in the 1st century of the Common Era, its presence is both graceful and utterly commanding, a double-decker bridge of stone that strides across the city plaza and vanishes into the distance. Its most astonishing feature is one you cannot see at first glance: the complete absence of mortar holding it together. Every one of its roughly 20,000 granite blocks was cut with such geometric precision that they locked together by gravity and friction alone, a dry stone puzzle on a colossal scale. This choice reveals a masterful, intuitive understanding of arch mechanics. The arch is a genius shape, converting the downward force of weight into an outward thrust along its curve. The Romans knew that for the arch to be stable, that outward thrust had to be perfectly balanced by the mass of the supporting piers and the resistance of the adjoining arches. By using massive, perfectly fitted blocks, they created a monolithic structure where each arch supports its neighbor, distributing the immense load of the water channel above and the stone itself down into the earth in a continuous, harmonious flow of force. It is architecture as a permanent diagram of physics, Yet the aqueduct's true purpose lay not in the arches, but in what they carried and the invisible line they followed. The water source was a mountain spring over 10 miles away. For the aqueduct to work, the channel atop those arches had to maintain a constant, gentle downhill slope all the way to the city, a gradient of perhaps only a few feet per mile. Achieving this over 10 miles of rolling, unpredictable terrain required a surveying feat of breathtaking accuracy. Roman engineers used simple but brilliant tools, the chorobates, a long, water-leveled sighting table, and the groma for establishing right angles. They plotted a course that tunneled through hills, bridged valleys, and followed contours with an unerring eye, ensuring that life-giving water flowed by gravity alone without pumps or external power for centuries. This was not a singular project of local genius. It was a standardized application of empire-wide knowledge. Segovia's aqueduct is one link in a vast network that stretched across the Roman world, from North Africa to northern England, a systematic program of civil engineering that prioritized public health, sanitation, and urban growth. It transformed cities from crowded, vulnerable settlements into centers of hygiene and stability, reducing the spread of waterborne illness and supporting larger, healthier populations. The aqueduct stands as a monument to a forgotten scale of systematic thinking, a legacy of durable, public-minded construction that would vanish from Europe for over 1,000 years after Rome's decline. In its silent, enduring flow, we see the pinnacle of an engineering philosophy that viewed infrastructure not as a cost, but as the very foundation of civilization itself. A monumental aqueduct channels water with geometric certainty, a testament to a known empire's reach. But what happens when a structure challenges the very map of history, suggesting an empire no record remembers? In the small town of Visoko, Bosnia, a series of hills rises from the landscape with an unusual, angular symmetry. One in particular, known locally as Visočica Hill, has become the center of a storm of controversy, rebranded by some researchers as the Bosnian Pyramid of the Sun. This is not a settled wonder, but a live, heated debate, and it forces us to confront the very process of how we recognize ancient genius. Proponents of the pyramid theory point to a collection of anomalous features. The hill's four faces align strikingly with the cardinal directions, a precision more common to architecture than to random geology. Its slopes, they argue, are too straight, too geometrically consistent to be purely natural. Excavations have revealed what appear to be large, man-made stone blocks fitted together, with a binding material that some analyses suggest resembles a primitive, high-quality concrete. Beneath the hills, a sprawling network of underground tunnels, known as Ravni tunnels, adds another layer of intrigue. These passages are lined with dry stone walls and contain what appear to be artificially placed megalithic stones, suggesting a complex subterranean component to the site. If these features are indeed the work of human hands from a distant prehistoric era, the implications are staggering. It would suggest a previously unknown, highly organized society in the heart of Europe, capable of landscape-scale engineering millennia before the Romans, potentially rewriting the early chapters of the continent's history. This possibility ignites the imagination, speaking directly to our fascination with lost civilizations and forgotten peaks of knowledge. Yet, the mainstream archaeological and geological consensus remains deeply skeptical. Most experts contend that Visočica Hill is a natural geological formation, a flat-topped mesa shaped entirely by ancient seismic activity and erosion. The angular sides, they argue, are a common result of such processes, and the so-called concrete blocks could be a natural conglomerate rock called breccia. The tunnels, while intriguing, could be medieval mines or natural fissures later modified by human activity. The scientific establishment has largely dismissed the pyramid claims, citing a lack of peer-reviewed evidence that meets rigorous academic standards. This clash is not merely about one hill in Bosnia. It is a profound case study in how we identify the fingerprints of the ancient past. It highlights the tension between intuitive observation and rigid scientific methodology. What one person sees as a deliberately shaped slope, another sees as a quirk of nature. This debate forces a critical question upon all of us. How do we distinguish a forgotten masterpiece from a remarkable accident of geology? The tools for answering that question are evolving. New technologies like ground-penetrating radar, LiDAR, and advanced material analysis offer fresh eyes, capable of peering into the earth or dating stone without a single shovel strike. The Bosnian pyramid controversy, regardless of its ultimate resolution, serves as a powerful reminder. It cautions us against becoming too certain in our current historical narratives. It suggests that forgotten knowledge might not always be buried under sand or jungle, but could be hidden in plain sight, camouflaged by time and our own assumptions, waiting for the right combination of technology, perspective, and open-minded inquiry to step forward and ask, what if we've been looking at this all wrong? The debate over a single hill in Bosnia asks us to question what we see on dry land. But what happens when the evidence itself is submerged, when the very ocean floor becomes a canvas for our deepest historical uncertainties? Off the remote coast of Yonaguni Island, Japan, the sea holds a secret that blurs the line between geology and architecture entirely. Lying about 80 feet beneath the waves, the Yonaguni Monument is a colossal sandstone formation that rises from the seabed like a sunken citadel. Its features are startlingly geometric. You can make out what appear to be vast, flat terraces stacked at near-perfect right angles. There are sharp, straight steps leading to a central platform. Pillars stand in formations that look carved, and a long, trench-like channel runs alongside the main structure. To the human eye, it feels undeniably designed. The immediate, instinctual reaction is to see a plaza, a staircase, a temple complex swallowed by the sea. This instinct fuels one of the most compelling theories, that this is the work of human hands from a time when sea levels were dramatically lower, over 10,000 years ago. If true, this would not be merely an old structure. It would be a relic from a prehistoric epoch, a product of a culture with the organization and skill to shape stone on a monumental scale, all before the dawn of what we recognize as civilization. It would imply chapters of human development, of maritime societies and their engineering knowledge that are completely absent from our history books, erased not by fire or conquest, but by the slow, inexorable rise of the oceans. Yet the ocean is also a master sculptor. The opposing view held by many geologists is that what we are seeing is a spectacular natural phenomenon. The sandstone in this region is crisscrossed with natural horizontal bedding planes and vertical fractures. Over millennia, powerful tidal currents could have exploited these weaknesses, eroding the rock along these straight lines and creating the illusion of platforms, steps, and pillars. The process, known as differential erosion, can produce astonishingly regular shapes without any human intervention. The trench could be a collapsed section following a natural fault line. From this perspective, the Yonaguni Monument is a breathtaking example of pareidolia, our brain's powerful tendency to see familiar patterns, especially human-made ones, in random natural forms. This underwater enigma represents the ultimate frontier for our search. It forces us to confront the profound difficulty of distinguishing a forgotten masterpiece from a masterpiece of nature when the site itself is inaccessible, shrouded in shifting currents and marine growth. The tools of investigation here are as specialized as the environment, involving marine archaeologists and geologists using sonar mapping, core samples, and careful analysis of tool marks versus erosion patterns. The debate may never be fully settled, but its very existence opens a door in the imagination. it asks us to consider the vast, unexplored 95% of the ocean floor. If a formation as provocative as Yonaguni exists, what else might be lying in the abyssal dark? This idea transforms the world's oceans from simple bodies of water into the planet's largest potential archaeological site, a silent, liquid archive that could hold the sunken fingerprints of cultures we have never dreamed of. It suggests that the greatest repository of forgotten engineering knowledge might not be in the deserts or the mountains, but resting in the eternal quiet of the deep, waiting for the slow, patient work of discovery to bring its secrets back to the light. The silent, sunken stones of Yonaguni ask us to look down into the deep, but on the gentle plains of central Germany, a discovery asks us to look up to a time when the first farmers of Europe built their calendar not from rock, but from earth and timber. The Gosek Circle is a whisper from an unimaginably distant past, constructed around 4,900 years before the Common Era. This makes it older than Stonehenge by well over a millennium, a Neolithic sanctuary that marks one of humanity's earliest deliberate attempts to pin down the cosmos. From the ground, it appears as little more than a series of concentric circular ditches, but from above, its purpose becomes stunningly clear. This was a precise, open-air observatory engineered entirely from the landscape itself. The builders dug 2 concentric circular ditches and raised a wooden palisade wall inside them, creating a secluded, sacred space. They left only 3 gates, narrow openings that break the perfect circle. And here lies the encoded genius. 2 of these gates align precisely with the rising and setting points of the sun on the winter solstice, the shortest day of the year. The 3rd gate aligns to the summer solstice sunrise. This was not a lucky arrangement. It was a deliberate, communal act of celestial cartography. To achieve this, the builders needed a deep, shared understanding of the solar cycle, observed and memorized over generations. They had to translate that arc in the sky into a permanent mark on the ground, ensuring that on the pivotal day of the winter solstice, the rising sun would slice a beam of light directly through the southern gate, across the enclosure, and out the opposing gate at sunset. This is landscape engineering in its most primordial form. There were no megaliths to quarry, no stones to move across impossible distances. The tools were antler picks, wooden shovels, and human labor. The medium was the very soil beneath their feet. By modifying the environment in this specific, geometric way, they created a giant, functional instrument that could predict the turning of the year with reliable accuracy. The knowledge embedded in the Gosek Circle is twofold. First, it reveals an advanced practical astronomy, a science of survival that told them when to plant, when to harvest, and when to gather for ceremonies marking the sun's rebirth. Second, it demonstrates a sophisticated capacity for communal spatial organization. Enclosing such a large area with coordinated ditches and a unified wooden wall required a shared plan, directed labor, and a social structure capable of seeing a project through from vision to completion. This simple circle of earth and wood is a foundational blueprint. It represents the conceptual groundwork upon which all later monumental architecture would be built, the moment a society decided to permanently inscribe its understanding of cosmic order into the land itself. In its quiet, earthen curves, we see the dawn of a tradition that would eventually raise pyramids and temples, all beginning with a ditch, a wooden post, and a community watching the horizon, waiting for the sun to tell them it was time. The Gosek Circle marked time with earth and wood, a calendar open to the sky. But high on the arid Bolivian Altiplano, a different civilization chose to carve their understanding of time directly into a single, silent sentinel of stone. The Gate of the Sun at Tiwanaku is not a gate in any functional sense, but a monolithic portal of meaning. Hewn from a single, massive block of andesite weighing roughly 10 tons, it stands alone, a testament to a culture that viewed engineering as a sacred act of inscription. Its journey to this windswept plain is the first layer of its mystery. The andesite was quarried from a site over 50 miles away, across a rugged landscape over 12,000 feet above sea level. Transporting this dense 10-ton block required not just manpower, but a profound knowledge of the terrain and a coordinated social effort that could orchestrate such a move without the wheel or draft animals. Once in place, the true marvel began. The surface of the gate is covered in intricate, low-relief carvings of breathtaking precision. At its center presides a figure often interpreted as a celestial deity, radiating authority, and surrounded by a procession of winged attendants and condor-headed beings. The lines are sharp, the curves fluid, all executed without iron or steel. This suggests a masterful use of abrasive techniques, where craftsmen patiently ground the hard andesite with sand, water, and harder stones, possibly guided by perishable templates to ensure the complex iconography remained consistent across the vast surface. This fusion of brute logistical strength and delicate artistic control is impressive enough, but the carvings may hold a deeper code. Many researchers see in the symmetrical, repetitive glyphs not merely decoration, but a sophisticated calendrical system. The theory proposes that the imagery represents a solar-lunar calendar of 290 days, a count that could have been used to track agricultural cycles, ceremonial dates, and astronomical events in the harsh, high-altitude environment. If this interpretation is correct, the Gate of the Sun becomes something far more profound than a monument. It transforms into a permanent public archive. The stone itself is the medium, the carvings are the data, and the knowledge of how to read it was the key. Here, engineering is not separate from cosmology, it is its physical expression. The act of moving the stone was an act of devotion, the act of carving it an act of scholarship. The gate symbolizes a worldview where the practical mastery of the physical world, the logistics of transport and lithic technology, was completely intertwined with the esoteric mastery of the cosmic order. It was a society that built its understanding of time, divinity, and survival into the very fabric of its architecture, ensuring that their most vital knowledge would outlast empires, written in a language of stone meant to endure for eternity. This seamless unity of purpose, where a structure is both a feat of strength and a library of stars, challenges our modern compartmentalization of science, art, and spirituality, suggesting that for these builders, they were all part of the same profound conversation with the universe. That silent stone gate in Bolivia speaks of knowledge made permanent, yet permanence itself is a material secret, one that the ancient Romans mastered so completely they built a world with it. Their greatest legacy is not a single temple or aqueduct, but the very substance from which they were made, a forgotten alchemy of earth and water called opus cementitium, their revolutionary concrete. This was no ordinary mortar. While modern Portland cement, invented in the 19th century, eventually cracks and crumbles under chemical attack, Roman concrete performed a miracle. It grew stronger with age. The secret lay in a deceptively simple recipe, a blend of lime, aggregate, and a magical ingredient, a fine volcanic ash known as pozzolana, mined from regions like Pozzuoli near Naples. When mixed with seawater, this combination triggered a chemical reaction modern scientists are only now fully understanding. Instead of just drying out, the mixture formed a stable, interlocking crystalline structure that could actually cure and harden underwater, a property called hydraulic setting. This meant the Romans could build directly in the sea, constructing harbors like portus that withstood the relentless pounding of waves for centuries. But the true marvel was its longevity. Over time, seawater filtering through the concrete would react with the volcanic ash and lime, forming rare, plate-like minerals that actually filled in micro-cracks as they formed. The material literally healed itself. This is why the breakwater at the harbor of Caesarea Maritima still lies intact beneath the Mediterranean, and why the dome of the Pantheon has survived Roman traffic, medieval markets, and modern pollution without a steel skeleton. This knowledge was a cornerstone of their empire, enabling not just monuments, but the infrastructure of civilization, the vast bath complexes heated by hypocausts, the sprawling aqueducts, and the resilient roads. Yet, with the political and economic collapse of the Western Roman Empire, the systematic production of this high-quality concrete faded. The precise recipes, the sourcing of specific volcanic materials, the practiced mixing techniques, all this granular, material-level engineering wisdom slowly dissolved into the past. For over 1,000 years, builders in Europe made do with weaker, less durable mortars. The pinnacle of ancient material science became a ghost in the recipe books, its physical evidence standing all around, yet its formula utterly lost. Today, in a profound reversal, modern materials scientists are conducting advanced X-ray and spectroscopic analyses on 2,000-year-old Roman piers, not to teach the ancients but to learn from them. They are racing to decode the exact geochemical processes that gave this concrete its self-healing power, hoping to replicate it for modern seawalls and nuclear waste containment, structures that also need to endure for millennia. This pursuit highlights a humbling truth: foundational knowledge is fragile. The Romans built for eternity but forgot how they did it, leaving their most resilient creations as silent teachers for a future that had to rediscover, molecule by molecule, what they once knew by hand and eye. The forgotten alchemy of Roman concrete speaks of a society that could transform liquid stone into eternal form. But across the Channel in Brittany, a different kind of transformation took place, one that turned an entire coastline into a forest of silent questions. The Karnak stones are not a single monument, but a landscape rewritten. Over 3,000 prehistoric standing stones march across the fields in long, parallel rows, some lines stretching for miles like regiments of ancient soldiers frozen in time. Erected during the Neolithic period, beginning around 4,500 years before the Common Era, this is not architecture as we typically understand it. There are no walls, no roofs, no intricate carvings. This is engineering stripped down to its most elemental form, the placement of a single, repeated object multiplied across a vast canvas. The sheer logistical scale is its first, overwhelming message. Each of these menhirs, some towering over 20 feet tall and weighing many tons, had to be sourced from local granite outcrops, detached from the bedrock, shaped, transported, and finally erected upright into carefully dug pits. The effort for one stone would be considerable, but to do this not dozens, not hundreds, but thousands of times, represents a societal commitment of breathtaking duration and unity. This was a project that spanned generations, a long-term vision executed with a patience we can scarcely fathom today. The purpose behind this megalithic forest remains one of Europe's great archaeological debates. Were these alignments a giant astronomical calculator, their rows pointing to solstice sunrises or lunar standstills? Could they have marked territorial boundaries for grazing or ritual processions, turning the land itself into a sacred map? Or were they a spiritual conduit, each stone representing a connection between the world of the living and the realm of ancestors or deities? The truth may encompass all these ideas, but the undeniable legacy is one of social power. To organize the labor, feed the workers, and maintain the cultural will to complete such a landscape-scale modification required a highly structured, cooperative society with shared beliefs powerful enough to move literal mountains, one stone at a time. The genius of Karnak lies in its philosophy of impact. It demonstrates that monumental design does not require structural complexity. By prioritizing arrangement and sheer quantity, the builders used minimalistic elements to create maximum psychological and visual effect. A single standing stone is a curiosity, 1,000 of them, arranged with intentional order, becomes a territory of the mind, an environment that commands awe and dictates movement. This is engineering as place-making on a grand, almost territorial scale, a way of saying we are here, this land is understood, and it is forever changed by our presence. In these silent rows, we see a forgotten blueprint for shaping human experience, not through enclosure, but through alignment, using the simplest of forms to write a permanent statement across the earth itself. The silent, regimented stones of Karnak declare a presence upon the land, but another ancient society chose a quieter, more intimate dialogue, one that listened to the hidden pulse of the earth itself and drew life from it. In the vast, arid heart of the Persian Empire, survival depended not on moving monuments but on moving water. The solution was a masterpiece of invisible engineering, a network of underground rivers built by hand, known as the Qanat. For over 3,000 years, these hidden channels have silently sustained cities and farmlands in some of the world's most inhospitable deserts. Their principle is one of elegant simplicity, yet their construction was an act of profound, forgotten genius. It begins high in the foothills of a mountain range, where rainfall and snowmelt seep into the ground, forming a subterranean aquifer. The builders of a Qanat would first locate this precious water table, often using generations of observational knowledge passed down through families of skilled diggers, the Mukanis. Then they began a project that was equal parts mining, surveying, and hydrological art. They would dig a mother well, a deep vertical shaft down to the aquifer. From this source they planned a gentle, downhill tunnel, often miles long, that would carry the water by gravity alone to a settlement or farmland on the plains below. But here was the staggering challenge. The entire tunnel had to maintain that precise, shallow slope, sometimes as little as 1 foot of drop per mile, while being dug entirely underground from multiple points. The solution was a signature pattern that still scars the desert landscape today, a line of craters stretching from the mountains to the oasis. At regular intervals, sometimes every 100 feet, the diggers would sink another vertical shaft down to the level of the planned tunnel. These shafts served a dual purpose. First, they provided air and light for the teams working deep below, who would excavate the horizontal tunnel in both directions from the bottom of each shaft, meeting their neighbors in the dark with astonishing accuracy. Second, and most brilliantly, they created a permanent maintenance and access system. For centuries, Mukanis could descend these shafts to clear silt, repair walls, and ensure the life-giving flow never stopped. The precision required was immense. Using only simple tools like plumb bobs and water levels, these ancient surveyors had to ensure that each new section of tunnel maintained the exact gradient, for a slope too steep would erode the channel and cause collapse, while a slope too shallow would stop the flow entirely. This was a three-dimensional puzzle executed in total darkness, a testament to a specialized, oral tradition of engineering that understood the intimate conversation between rock, water, and gravity. The result was a technology of sublime sustainability. By flowing underground, the water was protected from the blistering desert sun, losing virtually nothing to evaporation. It arrived clean and cool at the surface, where it could be distributed through canals to irrigate lush gardens, fill public cisterns, and power mills. The Qanat did not deplete the aquifer, it tapped it gently, in balance with its natural recharge. It created microclimates and fertile belts of green in the barren landscape, allowing great cities like Persepolis to flourish. This was ecological engineering in its purest form, a system that worked in harmony with the geology and hydrology of a place, not against it. It provided a reliable, democratic water source for millennia without pumps, without fossil fuels, and without degrading the environment that supported it. In a modern world grappling with water scarcity and the consequences of over-extraction, the ancient Qanat stands as a quiet, powerful lesson. It represents a forgotten pinnacle of knowledge, not of how to dominate nature, but of how to listen to it, to understand its hidden rhythms, and to craft a lasting partnership that sustains life across generations. The gentle, sustainable flow of the Kanat reveals a knowledge of working with the Earth's hidden gifts. But in the highlands of southern Africa, a different kind of stonework emerged, one that did not hide its power but proclaimed it from the summit of a hill. The granite walls of Great Zimbabwe rise from the landscape with a quiet, formidable grace. This was not a temporary settlement, but a thriving medieval city, a hub of trade and political power that flourished between the 11th and 15th centuries, long before the first European ships rounded the Cape of Good Hope. Its most defining feature is its architecture, a stunning display of dry stone masonry crafted entirely without mortar. The builders worked with the local granite, splitting it into rectangular blocks and shaping them with a patient, masterful skill. They then stacked these blocks into walls that curve and flow with the contours of the land, most famously in the structure known as the Great Enclosure. This vast circular wall, standing over 30 feet high in places, is not a simple ring. It is a complex serpentine barrier that weaves in and out, creating a labyrinth of passages and a towering conical tower at its heart. The construction is a lesson in intuitive engineering. The curved design was not merely aesthetic, it was a brilliant structural choice. A curved wall is inherently stronger than a straight one, better able to withstand lateral forces and distribute weight evenly. The gradual inward slope of the walls as they rise adds to this stability, a principle seen in other great walls across the world, but developed here completely independently. The precision of the stone fitting is remarkable. The blocks were so carefully selected and placed that the walls have endured for over 6 centuries through wind, rain, and time, their joints still tight, their presence still commanding. This city was the heart of a kingdom that controlled trade routes stretching from the interior of Africa to the coast of the Indian Ocean, dealing in gold, ivory, and other precious goods. The scale of the complex, with its separate areas for the elite, the citizens, and its impressive fortifications, speaks of a highly organized society with specialized craftspeople, sophisticated urban planning, and a clear social hierarchy. The profound significance of Great Zimbabwe lies in this very narrative. For generations, colonial accounts refused to believe that an African civilization could produce such an advanced, monumental city. They invented fanciful stories, attributing its construction to Phoenicians, Arabs, or even the biblical Queen of Sheba, anyone but the ancestors of the local Shona people. The true story, uncovered by archaeology, is one of autonomous genius. Great Zimbabwe stands as an irrefutable testament to the fact that advanced engineering knowledge, complex statecraft, and artistic vision were not the exclusive property of Europe or Asia. They emerged uniquely and powerfully across the globe, wherever human societies reached a certain pitch of cultural and economic complexity. Here, in these silent, soaring walls of fitted granite, we find a forgotten chapter of human achievement, a masterpiece of stonecraft that reclaims its rightful place in the global story of ingenuity, reminding us that history's greatest structures were built by many hands in many lands, each speaking a different but equally profound language of stone. Granite walls, concrete domes, and earthen circles speak in different tongues, yet their stories converge on a few profound truths. Having walked among these 25 silent teachers, a pattern emerges from the chaos of centuries, a shared grammar of stone written by cultures that never met. The first and most haunting refrain is the skyward gaze. From the solstice gates of Stonehenge and Gosek to the solar alignment of the Pyramid of the Sun and the lunar tracking of the Antikythera mechanism, we see a universal human impulse to pin down the cosmos. This was not mere stargazing, it was a foundational engineering parameter. To build a true monument was to anchor it in the eternal, to weave the turning of the seasons and the paths of celestial bodies directly into the floor plan. The precision required, whether aligning a pyramid's face or a temple's axis, demanded a deep, observational astronomy, a science born from patience and passed down through generations. It reveals that for our ancestors, the greatest structures were bridges, physical places where the earthly and the heavenly realms could meet. Equally universal is the puzzle of mass. An 800-ton block at Baalbek, an 80-ton Moai on Easter Island, a 2.3 million block pyramid in Giza, cultures separated by oceans repeatedly chose a scale that seems to defy their means. And yet they all discovered similar solutions: the principles of leverage, the use of inclined planes and rollers, the clever application of counterweights and pivots. These are not inventions of a single genius, but rediscoveries. They are the logical conclusions reached by any society that stares at a massive stone and asks, how do we make it move? The walking theory of the Moai, the stone ball bearings of Malta, the log rollers of Baalbek, all are variations on a theme, proving that the fundamental physics of moving weight were accessible through careful observation and relentless experimentation. This trial and error knowledge, refined over generations, became a form of communal wisdom, a toolkit as vital as the stone itself. Perhaps the most intimate pattern is the dialogue with material. The Romans did not just use concrete, they listened to it, crafting a recipe that would heal itself. The Inca stonemasons did not just cut rock, they understood its grain and its desire to lock together under pressure. The builders of the Hanging Temple knew the flexibility of oak and the steadfastness of their cliff. This was an empirical science, a knowledge built from thousands of hands touching, testing, and learning from failure. They understood stability not through abstract formulas, but through the feel of a settling stone and the sight of a wall that had weathered 100 storms. This hands-on mastery allowed them to achieve feats of durability we struggle to replicate today, not because we lack intelligence, but because we have, in many ways, lost that prolonged, intimate conversation with raw material. So what then was truly forgotten? It is rarely the basic law of physics. Gravity worked the same in Peru as it did in Lebanon. What vanished were the specific cultural recipes, the social blueprints, and the integrated visions. We lost the exact volcanic mix for Roman concrete, the precise organizational rhythm that could coordinate thousands to build a stepwell or a canat, and perhaps most importantly, the holistic worldview that saw no separation between these acts. In the ancient mind, engineering was not a standalone discipline. It was the physical expression of astronomy, a form of communal worship, a dialogue with the landscape, and a covenant with the ancestors. The quarryman, the astronomer priest, and the farmer were all part of the same continuum, building toward a meaning that transcended mere function. Our modern world has fragmented this unity, specializing knowledge into isolated fields. We can calculate stress loads with incredible precision, but we sometimes forget to ask what the building is for, how it speaks to the human spirit, and how it will converse with the earth it rests upon for the next 1,000 years. These 25 structures are not just relics of lost techniques, they are mirrors held up to our own fragmented age, asking us what we might be missing when we prize efficiency over endurance and specialization over synthesis. Their greatest lesson may be that the pinnacle of engineering is not measured in tonnage alone, but in the depth of the conversation it sustains between people, with the planet, and across the boundless stretch of time. These silent monuments are not relics of a finished past, but living conversations carved in stone. From the pyramids that chart the stars to the kanats that sing with underground rivers, each one poses an active, relentless question to our modern age. They stand as permanent challenges to a comforting story we often tell ourselves, the myth of linear progress. We imagine history as a steady, upward climb from primitive to advanced, but these structures reveal a far more complex and humbling truth. Knowledge is not a ladder we simply ascend, rung by rung. It is a landscape of brilliant peaks and deep valleys, where entire mountains of understanding can be obscured by the fog of time, only to be glimpsed again centuries later by a civilization that must learn their secrets anew. The self-healing concrete of Rome, the celestial computer of Greece, the seismic dance of Inca walls, these were pinnacles reached and then, astonishingly, forgotten. They whisper that our technological heritage is fragile, that the greatest breakthroughs can slip through the fingers of history if the culture that cradles them dissolves. Yet within that fragility lies an even more powerful revelation. Each precisely placed block, each alignment to a solstice sunrise, speaks to a universal toolkit of the human mind. It was not advanced machinery our ancestors lacked, but rather, they possessed something we have often undervalued: patient observation married to profound communal purpose. They spent generations watching the sky, learning the grain of stone, and listening to the whisper of water in the desert. They organized not for profit, but for a shared vision that connected them to the cosmos and to each other. This fusion of careful seeing and collective will is what allowed them to move mountains, literally and figuratively, with nothing but rope, lever, and an unwavering belief in the possible. As we face our own monumental challenges, from environmental resilience to building sustainable cities, these ancient teachers offer a quiet lesson in humility and inspiration. They ask us to look beyond the next quick fix and consider the 1,000-year solution. They remind us that sometimes the most advanced path forward is to become a student of the past, to rediscover the wisdom of working with nature rather than against it, of building for endurance rather than expediency. The true legacy of these 25 wonders is not in their scale but in their perspective. They invite us to widen our gaze, to value patience as much as power, and to remember that human ingenuity, at its best, is a conversation across millennia. If this journey through forgotten engineering has sparked your curiosity as it has ours, we would love to hear your voice in the conversation below. Which of these structures left you the most amazed, or wondering what other secrets might still be hidden in plain sight? For more deep dives into the greatest mysteries of our shared past, be sure to subscribe and join us as we continue to explore.